Hello, this is Hui. Welcome to watch my video C++ Programming on Linux. In this short video, we are going to discuss OpenMPI C++ library. MPI stands for the Message Passing Interface. It's technical for running process in parallel on single nodes or on multi-nodes of a cluster environment. It's widely used in the high-performance computing communities. In this short video, we are going to use OpenMPI for demo. It's just because it's open source, it's free, and also it's easy to set up and use. So OpenMPI is open source for high-performance computing applications. It's a high-performance messaging passing libraries. The OpenMPI project is an open source messaging passing interface implementation. It's mostly for the high-performance computing community. It's designed for running process in parallel. This website is open-mpi.org, and there's a lot of document discuss, community discuss under this page. So the most recent version of this OpenMPI is 4.1.1. Here there's a download. Click here and download. Currently stable release download is 4.1.1. So because we are going to install on the Linux, so I download .tar.gz files. Here on the Linux, I have this OpenMPI 4.1.1.tar.gz files. For installation, we have 6 steps. So first, untar or unzip this using tar -xzvf and file names. This going to untar and unzip and extracted the content into extracted directories. So let's run this. You can see now we have extracted under this directory. So the second step, we have to get into this extracted directory and running configure. So this step will be scan your system and generate the makefile for compiling. After configure completed, we can run in the make, which is compile our program under the local directory, which under this extracted directories. Step file have to be in the super user or root and running this make install. So make install is copy or install compiled library header file, setup file to the root directory. Step 6 is to running LD configure. This LD configure will be refresh the LD cache, which is bring our new generated library into LD cache. So our compiler can find that libraries. Because the compiling and the installing take a long time, so in this short video, we are not going to demo, just a simple 1, 2, 3, 4, 5, 6 steps. Now after we finish this step, how to verify this? First, as a C++ library, we have to check the header file. By default, header file was copied, installed under the user local include directories. So you can see after we installed, we have a few mpi.header file. Most important is mpif.h, and also we have to check the library. So the library installed under the user local library directory. So you can see we have a few MPI library and the MPI ISO library, and also we have a folder called OpenMPI, and we have a lot of library.iso file, and this is the library after we compiling and installed. Also, we have some utilities installed user local bin directory. So like MPI C++, which is the MPI compiler, and MPI run, which is the utility. We run the process for parallel, and also MPI CC, MPI C++. When you're compiling your program using G++, you have to use this for link. If you compile your program using the GCC, and you have to use this compiler. So in this video, we just demo using this MPI C++ and MPI run, these two utilities. And also we have to set up an environment path, make our tool utility able to find and anywhere in our test directory. We just type. You can see we are able to find this, and also this MPI run, this tool we are going to use in this demo. In order to test our MPI installation, we create a simple program called MPI version.cpp, which we try to print out what the version we installed, and here's the make file. So this is a very simple program. We declare some integer, rank, size, length, and we declare a chair buffer, which is called a version, which is a maximum library version string size. In order to use MPI, first we have to include a header file, which is called mpi.h, and we start, you call the function called mpi_init, and this for initialize and set up environment for running MPI. Finish the application, we have to call the mpi_finalize, which is clean our system. So in this program, we did very simple. First, we use the MPI get library version function to get our version. It's a character string defined here, and the length of this string. This function returns the version of MPI we installed. And we also use another function called mpi_comm rank. Return the value is the rank, which is an integer, and this is a predefined MPI comm word. And also we call the function called mpi_comm_size, and we got back to the size. So the rank and the size, there's a special meaning in the MPI applications, because this process for MPI is designed for running process in parallel. If we running this process in parallel in two, and the rank is the number of each process. For example, if we run this program in two processes parallel, and the first process, the rank is 0, and the second process, the rank is 1, and the size is the total process. To verify this, we just print the rank and size and print out the version. So this is a very simple program for testing. When we do the compiling program, we need to create a making file, and we use make to compile. In the making file, we define the two compilers. One is called G++, another is MPI CXX, which is MPI C++. Our program source code, mpi_version.cpp, we using the G++ to compiling our program source code .cpp into the object file .o file. And then we have to use the MPI CXX, which is MPI C++, to link our object to the executable, and the executable called MPI_version. So let's save this. Let's compile this. Now we got it compiled. This is our executable. In the normal C++ program, after compiled, we can directly running this program, which generate process. In this program, we can still running in the one process, so our rank is 0 and the total size is 1. So if we want to running this in parallel, we have to use the MPI utilities called MPI run. So this program, we have used an option called -np, which is to tell the MPI run how many process we are going to run. So we are going to run the -np. We try to run in 2, and this is our executable. You can see our process MPI version is running 2. So our size, which is this total process in parallel, is 2 because we selected 2. First process, the rank is 0, second rank is 1. OpenMPI can also be running on the multi-node environment, which we don't have this, so we are just running in the single node and multi-process. So if we running this in 4, now we got an error. This is there's no enough slots available in the system to satisfy the 4 slots that were requested by application. Since when we request running 4, our system don't have enough slot a slot in terms of the allocatable unit where we can launch the process. In a short word, Linux environment, which is I installed, and which is AMD dual process computer, which is I only have 2 process cores. So it means if I running 2 process, it works because I have 2 process. But if we run 4 process on the 2 processor hardware, we have to making some special setup. So here is the option. You can set up a host file. You can use the manual host command. The term of running more process than your processor is called oversubscriber. So we can use another option, which is manual oversubscriber, which means we know we have 2 processor, but we just want to run 4 process anyway. So in this command, we have to use this manual oversubscriber. So now let's try to say run. Now we are able to running this process in 4 parallel, and we have a total size is 4, and our rank is 0, 1, 2, 3. So each process we running have a unique ID called rank. Here is the way we running process in parallel. MPI stands for the messaging passing interface. So when we running our process, it's in the 1, 2, 3, 4 parallel. How to have communicated between each other. For example, if we want to send a message from the process 0 to process 1, that's we need to using this MPI mechanism or algorithm. So we create a program, test program called MPI test.cpp, and in order to run MPI, we have to include a header file mpi.h. And also, before we start our MPI application, we have used MPI underscore init, which is set up environment, and finish. We have to use MPI underscore finalize, clean all the systems. So here in the program, we make it very simple. Declare the integer called rank. As we say, rank is the process ID if we running multiple process parallel. So we using the MPI underscore com underscore rank to get the rank of current process. If the rank equals 0, it means our first process. And we declare an integer called value send. We just hard code give the value, which is 17. Then we can use a function called MPI underscore send. This function, which is a send value to the other process. So this MPI send, and the first parameter is the buffer, which is the buffer of our value we want to send to other process. So it's the address for val underscore send. And the second is the count, which is 1. Which the third one is the MPI data type, which called the MPI int, which is specified in this header files. Here is MPI.h, where defined the MPI underscore int. OpenMPI support this kind of type, and MPI char, MPI short, and MPI long, MPI float, MPI double, MPI long double. This is old C-type data types. So here we are simple. We just create an integer. We're using the MPI int. We try to send 17 to other process. So the next parameter is int test. It means another process. And 1 means send to the rank 1. Next is the targ. Targ is 0. And after that is MPI com. If this send success, we can print out from rank 0 send the value to the rank 1 target 0. So for the second process, should be the rank equal 1, and we declare the integer wow underscore RCV, which is the value we received. Is the function we're using, so we call them MPI underscore RECV. This function, the first parameter is the pointer of buffer address of our value received. And the second one is the int count, which count is 1, only 1 value. And the third one is the MPI date type, which is MPI int. And okay, so the next one is int source. Because the receiving, we need a source. So which source we receiving? We source from the rank 0. This is rank 0 sent to rank 1, and rank 1 receiving from rank 0. And the tag is 0. They send to the rank 1 tag 0, and the receiving tag is 0. And after that is MPI command. It's MPI command word. It's macro defined from this MPI init. And last one is the status. We just ignore the status. And if this result is success, we can just print out. We indicate the rank 1 received. What we received? We received the value RECV, which is from the MPI receiving function, and we are receiving from the rank 0 tag 0. So we're receiving from rank 0 tag 0, and after that we just get out. So test, if we running this process in 2 parallel, we can send a message from 1 to second process. So now let's just save this. Let's compile this. Now we got it compiled. So this is our executable. So to running this in 2 parallel, we running using MPI run -mp2. So we running this in 2 process parallel. You can see we got this from rank 1 0. We send 17 to our rank 1 tag 0. And here we from rank 1 received 17 from rank 0 tag 0. It means when we running this in parallel processing, we can send a message between each process. Hello, this is Hui. Thanks to watch my video. Hopefully this is useful, enjoyable. It's going to be great to have your feedback.